All right, we'll give folks maybe 1 or 2 more minutes to join, and then we'll go ahead and get started. And thank you, everyone, for joining our session this morning or afternoon, depending on where you are. All right. Well, welcome, and thanks so much for joining the session, Advancing Integrated Wastewater Management for Ocean Health. If you can go ahead and drop your name and organization and where you're calling in from in the chat, that would be greatly appreciated. This session is hosted by the Nature Conservancy and the Ocean Sewage Alliance, and we're really excited to be featuring speakers from Auburn University, RARE, the Center for Behavior and Environment, and the Urban Ocean Lab. For today's session, we'll have a Q&A at the end of the talks. And at that point, you will make it so that you can unmute yourself and come on video. But if you have questions that come up throughout the speakers, please feel free to drop those in the chat and we'll be tracking that throughout. Next slide. All right, so why are we here? We're here to talk about wastewater management in the context of ocean health. And if you're near the coast, chances are that the wastewater generated will eventually end up in the ocean. That's because we generally try to get pollution to the ocean as quickly as possible, either through ocean outfalls or by discharging it to the surface in groundwaters that eventually flow to the sea. But this practice has serious consequences for both people and nature. Threatens human health, with polluted water resulting in as many as 1.4 million deaths each year. And it also has significant consequences on critically important marine and coastal ecosystems. Next slide. So when we consider the scope and prevalence of wastewater pollution, this is not a localized problem. It affects ecosystems and communities globally. And while densely populated coastal areas and low and middle income countries suffer the worst wastewater impacts on coastal ecosystems, nearly all coastal areas face some level of wastewater pollution. In fact, over 20 trillion gallons of domestic wastewater is produced each year, with only about 11% of that recycled, which is that little purple triangle in this big pie chart. And that means the rest is discharged to surface waters in the ocean, with nearly 50% receiving no treatment at all before discharge. And then that remaining 40% of wastewater receiving some level of treatment, but often not enough to fully protect people or nature. Next slide. And although this wastewater can introduce a whole suite of novel contaminants to the marine environment, a major concern is nutrients, with an estimated 4 to 7 million tons of nitrogen introduced into coastal environments each year from both treated and untreated wastewater. Elevated nutrients, including nitrogen, fuels rapid algae growth, leading to algal blooms that deplete oxygen and limit light, creating dead zones and leading to biodiversity loss. Additionally, wastewater contains a whole suite of other contaminants that can also be harmful to marine ecosystems, including pathogens, endocrine disruptors, suspended solids, sediments, heavy metals, and microplastics. All right, now next slide. And this widespread exposure to wastewater contaminants is leading to real consequences for marine ecosystems. Coral reefs are particularly vulnerable, and over half of the world's coral reefs are exposed to wastewater pollution. Nutrients from wastewater can lead to too much algae growth, smothering corals, and when coupled with low pH, nutrients can increase the bioerosion of corals. Additionally, around a third of seagrass beds and salt marshes are exposed to wastewater pollution globally, with wastewater linked to decline of both of these ecosystems and a reduction in their ability to store carbon. So why does this matter? Well, the 3 ecosystems highlighted in this slide, coral reefs, seagrass meadows, and salt marshes, are all foundational to the health of our oceans and coastal communities, providing essential habitat, food, and critical nursery grounds for marine species, and they're all currently hurting from massive global declines. And climate change is making the problem of wastewater pollution even worse. Wastewater pollution makes ecosystems more vulnerable to climate change. Climate change also weakens our coastal wastewater infrastructure. Oh, sorry, next slide. Thanks. Yeah, so wastewater pollution can is also making ecosystems more vulnerable to climate change. Climate change also weakens our coastal wastewater infrastructure with rising sea levels and changing storm frequencies, damaging infrastructure and affecting wastewater treatment efficiency. This creates this vicious cycle, which you see here, where wastewater pollution weakens ecosystems like coral reefs and salt marshes, which in turn are crucial for protecting our coasts against the increasing threats of rising waves and storms. So our ability to deal with climate change and protect coastal areas is closely linked to how well we manage and treat wastewater. Next slide. So wastewater pollution is a complicated problem with serious consequences. The really encouraging part is that we're seeing more examples of how when we combine good coastal management with efforts to reduce wastewater pollution, this can lead to public health benefits as well as ecosystem recovery and make ecosystems more resilient in the face of climate change. Next slide. So today's session will focus on some of those success stories. We'll learn about technologies that already exist to protect coastal habitats and ocean health. We'll discuss how a behavioral approach to wastewater management can enhance the adoption and effectiveness of treatment options. And we'll also examine how supportive policy and governments can ensure communities have the resources needed for successful wastewater infrastructure implementation. Next slide. So with that, I'm really excited to introduce our fantastic speakers. We have Dr. Jillian Maxey Brown, who you'll be hearing from next, who's an assistant professor of civil and environmental engineering at Auburn University, where her research focuses on equity challenges in wastewater across the US. Next, after that, we'll have Katie Williamson, Senior Manager of Learning and Tools at RARE's Center for Behavior and the Environment, an international conservation organization focused on behavior change and environmental protection. Then we'll have Ali Carter, who's the Policy Director at the Urban Ocean Lab, who works on climate readiness for coastal cities and strengthening community resiliency. And then last, we have our co-convener, Jasmine Fournier, who's the Executive Director of the Ocean Sewage Alliance, who's a public health researcher, policy expert, and ocean enthusiast who will be rounding out the session. So with that, I'll go ahead and hand it over to our first speaker, Dr. Jillian Maxey Brown.
Thank you, Amy, for giving us such a great introduction and framing the topics for everybody. I'm going to be starting by talking about some of the innovative technologies. This is a summary of some of the key findings from a report I just finished up with the Nature Conservancy. So at the end, we'll have contact information if you're interested in seeing the full report. We're looking at how do we start to look at what wastewater solutions we could implement in communities that are having coastal wastewater challenges. Next slide. So as many of you are probably familiar with, the United Nations has a series of sustainable development goals that are looking at improving the lives and prospects of people throughout the world. A number of these are connected to wastewater and clean water, but also ocean communities. So number 6 is clean water and sanitation, and then 14 is life below water, but some of these other goals also touch on it as well. So next slide, please. When we're looking specifically at the sanitation or wastewater side of things, goal 6 is looking at achieving sustainable management by 2030 for every single person in the world. So to have safely managed access to sanitation means that your house has an improved wastewater facility that's not being shared with another house, and where that waste is being properly disposed of either at the home or is being transported off-site and properly disposed of. And then you can click. As of 2022, there were still about 3.5 billion people that didn't have access to safely managed sanitation across the world. So if we are to achieve this 2030 goal, we're going to need to increase the efforts by at least 5% in the next 6 years. Next. Thank you. So there's a number of sanitation guides that are out there, but many of them lack the guidance that are needed for coastal communities that are having wastewater challenges. These coastal communities have unique climate and geological conditions that they have to consider. Some of them are even island situations, so high island with high rainfall, but you also have low coral islands. And then the soil that you will see on islands can vary quite a bit. So you'll have some areas that have very high transport, but also you'll have areas that have more low porosity. So if you're looking at a wastewater solution that's going to discharge the wastewater into the soil for treatment, you're going to have to think about what part of the island you're going to be installing that system on. There's also some interesting supply chain context that you have to think about because some of these areas can't necessarily get the same sorts of equipment or supplies for wastewater technologies. And these areas will have ongoing issues in the future with how different human population trends are happening and different natural disasters. So, as you're thinking about installing or choosing what wastewater system you're going to design, you have to really be forward thinking as to what is it going to look like for the next few decades. Next slide. So when we're looking at wastewater solutions, we usually put them into four broad categories. The first one, or A, is a conventional sewer system. This is what we traditionally think of where an entire community or an entire city is connected to one centralized wastewater treatment plant. So all the homes and businesses in that area, all their wastewater flows to that one treatment plant. B is going to be a hybrid system where only the liquids are going to go to that centralized treatment plant. So every house has this little septic tank. That's what that little dot is underneath each home. And the solids will collect in that septic tank and the liquids will go to the centralized treatment plant. Another hybrid option is D, and this would be where each home still has a septic tank and all the liquids are going to go to a treatment unit, but it's going to be on a much smaller scale. So think like a neighborhood or a small portion of the island. Is not going to be the entire island going to one treatment plant. And then C is on-site systems. So this is where every single home has its own wastewater treatment system. So you can see a septic tank and then a little drain field. And if we go to the next slide, this is what a septic tank system, a conventional one, how it works. So the wastewater is going to flow from the home into the septic tank. And at the septic tank, the solids are going to settle out, and then the liquids will continue on to that drain field. And you'll see this is a subsurface discharge septic system. So all of the liquid waste from that drain field is going to go down into the soil matrix, and that's where it's going to be treated before it enters the groundwater table. So the soil matrix is going to be really important because there's bacteria in there. The soil particles themselves also act as a filter. But you could see how in a coastal area, if you have a very shallow groundwater table, you may not be able to get enough soil depth to have all of the viruses and bacteria removed from that wastewater. Next slide, please. So there's a number of different advanced types of on-site wastewater treatment systems. So you can see a number of them here. They take a component of that conventional and they modify it so that you can get the same level of treatment removal, even in different types of soil conditions, different groundwater tables. If you have sandy soil versus clay soil, there's a lot of different options out there. I want to draw your attention to the one in the top left, the aerobic treatment unit. These aerobic treatment units take a conventional septic system and they add a blower to it so that air is introduced and you can get advanced nutrient removal before the wastewater even goes to the drain field, which can be really helpful in coastal areas where you're near sensitive water bodies. Next. So, as part of this report, we put together this figure here, and it shows you your broad three categories of centralized sewer. You also have on-site options, and then decentralized clustered. So this is kind of a decision matrix to help you go through and pick based on which of these different three typologies you think is best for the community, what your different options are within each one. So you can see there's from centralized, you can choose whether you want to do solids and liquids or liquids only. And then if you want to use existing infrastructure or build something new. Within on-site, you can decide if you want to do black and gray water, and that's going to be all of the wastewater from the home, or if you want to just do the black water from a toilet. And then with the clustered systems, you can decide kind of how large of a system you want to do, how many houses are going to be connected to it, and how it's going to all be collected. And then we get to the treatment section, you'll see that there are some multi-stage tanks. So if you're in an area with more of it closer to a sensitive water body or a shallow groundwater table, you can have your regular septic tank, but then you can add one of these multi-stage treatment tanks to get even higher levels of nutrient removal. And then you go into your effluent disposal options. And these are going to depend mostly on what the regulations are for the area, whether you're going to go into a subsurface discharge or a surface discharge. But either way, you have a number of different technologies that you can choose, just depending on the situation for where you're at. Okay, next slide, please. So we also put together some questions that can guide a community as they're thinking about which of these wastewater typologies is the best for them. The first thing we want to kind of guide you towards is looking at what is the existing infrastructure, because you want to not be spending more money than you have to. You want to kind of look at what is existing in the area and how can that be leveraged to add more people to a wastewater solution. But if the existing infrastructure isn't working correctly, then we would recommend that you just start over with a new system. And part of that with the system is you have to think about what is your population size and what's your geographical size. Because if you can get more houses onto one system, it will be a lower cost per household, which can really help in low income areas. But you also have to think about how large the system is, because once you get going larger than a couple square miles, your cost to install that system is going to escalate really fast. As I already kind of mentioned the local geology is going to really drive what decision you're going to make for your effluent dispersal system, but also the type of treatment units you're going to need for how much nutrient removal you need. And that's also going to depend on where you're located and what the regulations are. Next slide, please. Some other things to think about is what's going to happen after the system is installed. So you have to have a management entity for some of these different typologies, especially if you don't have each individual home with their own system. You're going to need some sort of entity that can be in charge of the operation and maintenance of that system and collecting any sorts of bills that might be associated with that system. And you're going to need to think about the supply chain, not just from the installation side of the system, but also if something goes wrong with the system, can the equipment or supplies needed to fix that be procured in a reasonable amount of time for a reasonable price? And then lastly, you really have to think about these solids management. A lot of times the solids of these systems is an afterthought because it's not something you need immediately, but come about 3 years into the system, you're going to need to have some sort of infrastructure in place to make sure that those solids are being treated properly. These solids they're very dense with nutrients and pathogens and other disease causing like bacteria and viruses and things. So you need to make sure that they're being properly treated. Next slide, please. So there's a number of different options for how you can treat the biosolids or the septage from these systems, depending on whether it's coming from a centralized treatment plant or a septic tank. Both of those are solids that are going to need to be treated. And in coastal areas, depending on the type of treatment method, if you aren't properly treating it before land applying it, it could end up getting washed off into those coastal water areas, and it will end up with more damage than what it could have if you're looking at a system more inland. So making sure that there are certain regulations in place to ensure that that waste is being properly treated, not just to remove the nutrients, but specifically also the different disease-causing agents too. Next slide, please. So kind of in conclusion, the way that we ended up looking at solution recommendations from a centralized perspective, these systems would primarily only be recommended in areas where the community already has an existing sewer system, which a community could be added to. Like if you have a couple homes that need to be added to that sewer system, that would be the most cost-effective solution for them. But it's not going to be most cost-efficient to introduce a new centralized system into a new area because oftentimes they're very expensive to install. So that's why we would more so recommend on-site or decentralized cluster if there's not an existing sewer. With on-site systems near coastal areas, they really need to have advanced treatment. So you have that regular septic system and then another tank, or you're going to have one of those aerobic treatment units. The aerobic treatment units do have higher energy demands, but you could install solar panels to help keep that cost down. And those multi-stage treatment systems, the constructed wetlands or the packaged media biofilters or the sand filters, really just depends on what the community context is. And then, like I mentioned, regulations are kind of going to be your baseline for deciding what technology you're going to implement and how that liquid effluent is going to be dispersed. With these clustered systems, these are going to be really great for low density housing areas where you can have a group of homes connect to one system and they can share the cost of that system. Next slide, please. So in the report, there's a table that specifically outlines all those different typologies that you guys saw in the decision flow matrix, and it will go through and it talks about the benefits versus limitations for each one that can kind of help as you answer those guiding questions, deciding exactly which of those solutions, the different typologies would be best to answer your questions. Next. And then at the end, we're going to do all the questions together. But if you're interested in a copy of the report, Amy's email address is listed there. And once we're still working on some revisions to that report, but we'd be happy to share it with you. Thank you.
Wonderful. Thanks so much. Thanks, Jillian. And I will take it from here to share. And as she mentioned, my name's Katie. There are so many great wastewater technologies out there. And so with my presentation, I hope to bring in kind of a behavioral lens to wastewater pollution by sharing some ideas for how we encourage people to adopt these different technologies. Next slide, please. Wonderful. So the insights I'm going to be sharing today are going to be coming from RARE and our Center for Behavior and the Environment, as well as some partner organizations who are doing some really great work in this space. And so at RARE, we've been doing a lot of behavior change work in many communities around the globe, supporting these community-led efforts on different environmental challenges. Next. And so what I hope to share in my short time today is a little bit about why environmental challenges like wastewater pollution are behavioral challenges, levers of behavior change that we can use to make our environmental work more effective, examples and stories of wastewater and behavior change solutions, and then an approach for designing those behavior change solutions. Next. So first, just starting here around environmental challenges as behavioral challenges. Next slide. So virtually every environmental or social challenge that we have today is this behavioral challenge. And so we think about behavior as core to everything that we do. It's the actions that we take, what we eat, who we vote for, what we buy, how we show up for the causes that we care about. And these environmental challenges are made up of a lot of individual actions. So we can focus at the individual and household level, but it can also mean looking at leaders, politicians, business leaders, people at all parts of the system are all making decisions and taking action that are different behaviors. Next. So you might think that behavior is a pretty common word that we use in our language. And in this case, I'm using it quite specifically to describe the actions that people are taking. So those actions may be built on our beliefs or our attitudes, intentions, the context for behavior. But those are not exact substitutes for behavior itself in terms of what we ultimately want to change. So I have an example around recycling here, and you can see the difference between that behavior of recycling versus some of those maybe beliefs about you thinking recycling is important or your attitude that recycling is good for the environment. This can also be really helpful when we're measuring success of a solution to be looking at that behavioral outcome. So I'll just share some examples of, in the wastewater sector, some different behaviors that we might focus on. So in blue here, you can see different kind of pollutants and behaviors at the level of the agriculture sector. So looking at how farmers can construct wetlands, or they can, government officials can look at investing in different infrastructure that polluters are monitoring their discharge. We can also look at more of the human waste level. So as Jillian mentioned, looking at these different sewage management systems can be really important, and how people are replacing their own systems. And then at the level of plastics and other solid waste, looking upstream at some of those packaging behaviors and guidelines, and also at the consumer level of people using reusable products. And there are many others, but just a sample of those. Next slide. So now I want to dive in a little bit into these levers of behavior change. So this is a framework we use at RARE to look at the tools that we have for changing behavior. So I'll start with a very short overview of behavioral science before we dive in, which is to say that we have many factors that go into our decision making, and some of our decisions are really thought intensive, and some of them are fast and automatic. Almost seeming unconscious to us. And some are a bit of both. So we have this full spectrum of ways we make decisions. Next slide. So we often assume and like to think that our decisions are mostly made on the left side of this spectrum, which is to say that we think that we make a lot more decisions in this calculated, really thought-intensive way, when in reality, we make a lot more of our decisions very quickly and automatically. And so as a result, when we tend to assume that people are making these very thought-intensive decisions, we tend to rely more on strategies like material incentives, information, and also enacting rules and laws. And these can be really helpful levers, but we also have some other tools in our toolkit. So next slide, please. So at RARE, we like to talk about these 6 levers of behavior change. So these also include things like social influences. So how are we influenced by our peers and our colleagues, our family, our communities, the people who we look to for guidance for different norms? Emotional appeals. So how do our values, our interests, how we feel about our communities and these behaviors affect our behavior. And then choice architecture, which is a term to describe the context for decision making. So are there defaults, are there prompts in our environment that help to guide us? So together we think about these levers as different tools that we have to change behavior. So I want to give a few examples in the wastewater sector where we can see some of these levers at work. So this example is from an organization called Soil, and they're based in Haiti. And they really focus on providing dignified ecological sanitation in vulnerable and underserved urban areas. And they're focused on encompassing the full sanitation cycle from household toilet provision to waste collection to nutrient recycling and more. And they're using a bunch of different levers in terms of promoting household adoption of these. A few key ones are emotional appeals and their messaging around comfort and cleanliness and health. Social influences, they use peer referrals to help encourage adoption, and then material incentives through the convenience of this system. You can see here that it's kind of a pickup system. They've encouraged over 6,000 people to use these toilets, which is pretty great. Another example here is from Brazil and a research team at the Inter-American Development Bank. And this follows a story that even years after building sewer infrastructure, sometimes a small percentage of homes actually connect themselves to that infrastructure. And so this is a case in a neighborhood in Brazil where under 20% of the homes were connected. And so they wanted to see how can they increase that connectivity. And their solution through talking with community members was they needed a new norm and a shared identity. So they brought residents, they brought social workers and engineers all together to really help information gaps and set a new kind of community standard. And they were able to increase connectivity to 90% through these efforts. And so thinking about how we can use these strategies to harness that power of social influences. And then the last example I want to share comes from the central United States. And it's another great example of using social influences. And so a research team wanted to see if they could change wastewater discharge behavior of facility operators. And they tried using sharing comparison data between the facilities. So they did an experiment where 50% of the operators received comparison data from the other operators. So, you're using this much, you're discharging this much wastewater, and your fellow facility operator is discharging this much. And then the other 50% of operators didn't receive information. And they found that those who received the comparison data discharged about 7% less. And it had the biggest impact on those who were discharging a lot of wastewater. So just a great example of that social information. So the last part of my presentation is I just want to share how do we design these behavior change solutions? How do we know which levers to use? And so at RARE, we use an approach called behavior-centered design. And I'll just quickly describe what that is on the next slide. And so this is an approach that blends behavioral science and design thinking, which is a really human-centered methodology that puts people at the heart of solutions. And it has 8 steps to it. Next slide, please. These 8 steps include framing the challenge, so defining what is the behavior and actor that we're trying to solve. Empathizing with the challenge, so empathizing with our core actors, so learning about their motivations and barriers to change. Mapping those motivations and barriers to behavioral science. Ideating solutions, so coming up with ideas based on those. Prototyping and testing, so once we have our solutions, kind of getting feedback, seeing how they're doing, and then launching and assessing as well. So I think if you click through, you may see the definitions there as well, just for review. But to say that we go through this nonlinear process, and it's really iterative to learn about these motivations and barriers and design solutions. And on the last slide, I'll just end today with a recent application of behavior-centered design. So last July, our RARE team partnered with the Global Environment Facilities Caribbean Regional Fund for wastewater management, alongside a number of other partners to deliver a workshop on behavior change and wastewater management. And we provided 3 mini grants to projects in the wider Caribbean region who wanted to pilot these behavior change efforts. And so one of them I wanted to share with you today, just a short snippet of the work that they're doing. And so on the next slide, you'll see, we'll just watch maybe a little bit of this video. This is a group in the Dominican Republic called Plañaque, and they're working on using constructed wetlands to manage their wastewater.
Plañaque es una organización comprometida con la gestión sostenible de los recursos hídricos y la calidad de vida en la cuenca del río Yaque del Norte en la República Dominicana. Es para nosotros de gran valor el aporte que está haciendo el proyecto Crew Plus en nuestra zona por su contribución en nuestro propósito de mejorar la gestión de las aguas residuales en nuestro entorno, pero muy especialmente en la comunidad de Cristo Rey de Jarabacoa.
Mi nombre es Emmanuel Valga Sánchez, soy coordinador de la unidad Agua y Saneamiento en el Plan para el Desarrollo Sostenible de la Cuenca del Río Yaque del Norte. Estamos en la comunidad de Cristo Rey, donde estamos implementando soluciones basadas en la metodología de diseño de cambio de comportamiento para lograr la sostenibilidad a largo plazo del sistema de tratamiento basado en un humedal artificial.
Desde el Ayuntamiento de Jarabacoa hemos estado apoyando este proyecto porque...
Thank you so much. And I can share more of the video later if you're interested to learn about their work, but they've found that they want to encourage folks to maintain these wetlands, and they've been looking at what are the motivations and barriers to do so, including training, kind of making it easy. They've created a community fund, so some really interesting work that they're exploring. So that's most of what I have to share with you today. If you're interested to explore more about this, on the next slide, you'll just see some places where you can explore a little bit more. So we have a website, behavior.rare.org, with case studies and more insights. We also have, on the next slide, a particular microsite that we've created on behavioral insights and water pollution, and I can drop that link in the chat in case you're curious to check it out with more case studies. And then we also offer training and learning, so we'd love to have anyone come learn with us about applying these insights to their work. So thank you so much, and thanks for being here.
Hi, I'm Allie Carter. I'm the policy director at Urban Ocean Lab. We're a nonprofit based in the United States that works on helping our coastal cities be more ready for the climate crisis. And so I'm going to be going over a couple ways that different levels of government in the United States have implemented wastewater policy solutions in coastal cities. So thanks for having me. Next slide. U.S. water management policy kind of relies on a couple major tools, one of which is data and research. The second is effective regulations, and third I want to mention is adequate funding. So, like I said, I'm going to be going through a couple examples today of how different levels of government have used these kinds of tools to implement successful wastewater management projects in the United States. In the United States right now, the Environmental Protection Agency estimates that U.S. drinking water and wastewater systems will require an investment exceeding $744 billion over the next 20 years. And a lot of that is due to the fact that climate change impacts and urbanization are threatening the availability and quality of water resources. So coastal flooding and saltwater intrusion from rising seas is heightening the risk of wastewater infrastructure failure. Under a scenario of 6 feet of sea level rise, an estimated 31 million people in the United States could lose access to wastewater services. These are all kind of impending issues that policy and regulators really need to think about as we start looking at how to make better decisions around wastewater management. Next slide, please. There's been a lot of work at different levels of government, and within the United States, the federal, state, and city levels of government kind of work together in order to make wastewater management policy happen. So on the federal level, a couple of the major pieces that I wanted to mention include the Clean Water Act, which is what the Environmental Protection Agency uses to regulate the discharge and treatment of wastewater. They administer the National Pollutant Discharge Elimination System, which is a series of permits to all wastewater dischargers and treatment facilities that establish specific discharge limits, monitoring, and reporting requirements. They also require the facilities to undertake special measurements to protect the environment. And so a lot of this is dependent on the good science and data and research needed to identify what an effective regulation would be. And so it's been one of the kind of fundamental ways that nationally we regulate the way that wastewater is treated, because having that set bar nationally allows everybody to work towards a single goal. On top of that, another role the federal government plays in policy creation is funding. Funding is a huge issue. As you know, I mentioned the $744 billion over the next 20 years. Every level of government and every coastal community is going to need significant funding in order to achieve these results and to maintain, human and environmental health. And so two of the major ones that happened in the last couple of years during the most recent presidential administration is the Inflation Reduction Act and Infrastructure Investment and Jobs Act, which provided billions of dollars in federal funding to a variety of different projects, but they even included wastewater treatment. So the Inflation Reduction Act had $500 million in watershed and flood prevention operations, which is going to continue to be available over the next, I think, 5 to 6 years. It also included a $575 million climate resilience regional challenge, which includes any kind of resilience to climate change, including sea level rise, which will impact water management systems. And the Infrastructure Investment and Jobs Act included a $550 million disadvantaged community domestic water supply program, which helps disadvantaged communities access clean water and provide systems for water management. This is actually a new program also. So not only is it necessary to create funding opportunities for communities, but creating programs that directly address issues that we need handled, and including communities that are most at risk are going to be vital to making sure that we continue to make good decisions around wastewater management. Next slide. So at the state level, there's more of a hands-on approach a lot of times, because at the state level, you start getting, Water Resource Authority and other community or state level organizations and government agencies that can really address things on a more basin-wide scale. And so the example that I brought here is the Deer Island Wastewater Treatment Plant, which is outside of Boston, Massachusetts. It's actually over 20 years old. It cost $3.8 billion to make 20 years ago, and it took 10 years of construction to build it. So these kinds of projects are really a commitment for governments and communities to do. Oftentimes it takes a long time to put them into effect, but when they did it, one of the things they did is they raised the entire water treatment plant by 2 feet or 0.6 meters to avoid extensive costs associated with building a seawall to protect and keep the water out of the wastewater treatment plant. And so this ended up creating a much more resilient project that is projected to be effective and sufficient to withstand sea level rise for the life of the plant, which is fantastic for the 43 communities in the greater Boston area that this serves. By investing in this new wastewater treatment plant, they increased treatment capacity by 40% from 250 million to 350 million gallons per day. And they also have been able to regularly reevaluate and update this. So even though this is a little bit of an older example, I really like it because not only did they identify the vulnerability, they adapted to future conditions, and they did it in a way that is resilient to the climate crisis, but they continue to reevaluate the risk of this plant to ensure long-term effectiveness. And this reevaluation actually happened most recently in I think 2013 or 14, when they used a community nonprofit sea level rise estimate to evaluate future effectiveness. And so this is a great example of kind of including the community and community-based organizations, including data and scientific information, and making sure that the policies and decisions government make are going to be the most resilient for the longest term possible. Next slide, please. The last 2 examples I have are from 2 coastal cities in the United States. The first one is Portland, Oregon. They implemented their Big Pipe project, which was completed in 2001, costing $1.4 billion and took 20 years in construction. With this project, they now have a lot of really great data since it's been implemented, noting that they have nearly eliminated combined sewage overflows, and they reduced the overflow into the Willamette River by 94% and 99% into an additional slough, which significantly improved the river health. So coming out from that long period of time, they've seen significant environmental benefits within the local river ecosystem because of it. Before the big pipes, there were an average of 50 Willamette River overflows each year. Sometimes they lasted for days, but now an average of only 4 overflow occur each rainy season and only 1 every 3rd summer. Also, when these happen, they actually are a smaller volume and the duration is lower. And so this has been a fantastic success for Portland, Oregon. They also paired it with green infrastructure, including rain gardens that receive downspouts from roof drains, stream diversion to keep some of the local creeks flowing into the sewer system. And instead, they have redirected it to flow directly into the river so that it's not even a part of that. And they also constructed a 26-acre wetland in order to allow more storm sewers to feed into the wetland and have nature-based solutions effect there. Next slide, please. Washington, D.C. is our last city example here. They are implementing an ongoing project series of improvements that reduce combined sewage overflows and protect the Potomac and Anacostia rivers. They expect this to reduce CSOs by 96%. And they also have reduced flooding in chronically impacted areas in the Northeast boundary from approximately 50% to only 7%. They're also reducing nitrogen discharge into the Chesapeake Bay by almost 1 million pounds per year. They, through this project, they have conducted 18 miles of new tunnels and also now manage 92 previously impervious acres with green infrastructure through a local region and regional park. And so this is something that's an ongoing commitment by the city to continue to change the way that they do things in order to make sure that this benefits the community and the environment. So from these case studies, we can kind of formulate the following recommendations. Next slide, please. So with the recommendations that we have here, we recommend that comprehensive management of the full water cycle is best, because moving through and just addressing things only when there's an issue is not really the best way to do it, but actually creating kind of watershed scale or whole basin scale solutions that serve many different groups of people can be really effective. Unfortunately, funding and collaboration between different governmental entities can be more difficult because of that. And so it's important to have the scientific research and tracking information to help inform and make the case for why that should work. And then it's also important to have transparency and coordination between governments in order to make sure that different governmental agencies are working together in order to make these larger projects happen. We also recommend retrofitting, elevating, or relocating water facilities at risk from climate impacts. Infrastructure is going to need to change in order to adapt to the climate crisis. Facilities already at risk or lagging behind or coming to their operational end offer great opportunities to restart and do things in a way that are forecast to be resilient and effective in the long run, given best available science. We recommend mitigating combined sewage overflows to the best extent possible. This is, as we've seen with our other case study, our previous case studies, achievable, but it does come with the need to fund, with the need to plan, and the need to commit to it. And the last recommendation we have is to incorporate gray-green infrastructure with these projects to nature-based solutions can offer similar risk reduction as traditional infrastructure, but that also has added benefits of ecosystem services, habitat restoration, and sometimes even recreational opportunities. So some of those examples include stream diversion through parks, the wetland restoration, rain gardens, permeable pavements, and avoiding constructing new seawalls. So with that, that concludes my presentation. You can go to the next slide. We have a lot more resources on our webpage, so we encourage you to visit us at urbanoceanlab.org, where you can check out our resource hub and all of our recommendations and other policy products. Thank you.
Thank you, Allie, and thank you to Katie, Jillian, and Amy for spearheading this presentation. I've heard a lot of really interesting things, and I'm going to cut my remarks short so that we have enough time for a lot of questions that we have in the chat. So just to follow up on what Amy started with, dilution is not the solution to pollution, and actually it doesn't really work that well. There's some good data out of Scripps University showing that sewage dumped into oceans with tides, the tides actually aerosolize, the waves aerosolize the sewage and can actually push that aerosolized pollution into droplets as far as a mile back onto shore. So I think what we can start to think about is, here I'm lucky to be in Stockholm, and one thing I've noticed about the Swedes is they're very proud of their drinking water. At least 3 people have talked to me about how clean it is, and coming from New Orleans in the United States, it's really a mind change shift, because I think oftentimes we think of our rivers, lakes, and oceans as dumpsters. So how can we start to reimagine how we treat these waters? And one way is to think of like our presenters talked about where we're putting our sewage and wastewater. And again, I'm just going to be brief. There's not a one-size-fits-all solution for this problem. We've heard of different behavioral interventions, policy interventions, and cutting research that will help us to better understand the problem. Localized solutions are critical, because when I hear wastewater and sewage, I think, how can we be more drought resilient? How does that impact climate adaptations? How does that help us to replenish groundwater? How does it help us to improve drinking water? And how can it improve our marine ecosystems? As these are all just different sectors, but they're all tied together with sewage and wastewater, because you can think of sewage as an input to drinking water. I live in New Orleans, like I said, at the bottom of the Mississippi River, and we are de facto water use because there are 5 cities above us that are outputting their sewage and wastewater treated into our drinking water source. So how can we conceptualize this and think of ways we can improve it, such as having a circular water economy where we're keeping our water and using that as drinking water? So I'm just going to, again, be brief because I know that we're short on time. But if we can think of this problem as something that we all are able to do something about. Katie mentioned it, rare behavioral change. So let's say, like Ali mentioned, you're on a combined sewer overflow. If it's raining really hard, often the issue is that the rain floods the sewage and wastewater treatment plant. So as a person, I could not flush my toilet or wait to do my laundry. That's a quick, easy behavioral intervention. Or what policy interventions are happening in my area? Do I know even where my sewage is going from the treatment plant? So I encourage you all to think of if there's anything that you can do related to this large problem, because at the end of the day, it's localized solutions that will help to solve us. And this is my cat. This is a real photo. And I found out about a week ago that my sewer drain pipe was broken, and it was just discharging sewage right underneath my house. So even this little cat was able to hop in with her little run. So that being said, I would just like to open it up to questions, as we've got a lot and we're limited on time. So I'm going to stop the share. And I think, Claire, you'll be handling the questions.
So Claire's been tracking the questions in the chat. So I think we'll start there, just since we only have a few minutes left. And just before we jump into questions, I just want to mention that if any of the resources that our speakers discussed in their presentations are of interest, we are keeping track of email addresses that are dropped into the track, and we'll be sure to follow up with the resources described. So if you'd like that follow-up email, please just drop your email address in the chat. All right, so our first question is for you, Jillian. How can we address the problem of solid waste in countries like India, starting from rural areas? And they also wondered if there's any collaboration that could be initiated.
Yeah, so the area that I primarily work is in rural Alabama. And so it's kind of a similar situation. You got a lot of houses, but they're kind of spread out. So the way that we often start approaching the septage or the solids management side of things is we have to actually do a quantification of how many houses are there and where they're located, because these systems oftentimes need to be pumped down every 3 to 5 years. So that kind of determines how much volume we need to accommodate for, how many pumper trucks we need, things like that. So you kind of have to have an idea of the scale of the situation and geographical area first, and then you can start to think about what sorts of volume accommodations you need and how many pumper trucks and stuff. And I would say that there are a number of organizations out there that only focus specifically on the solid side, because it's something that's been neglected for years. We oftentimes have only been thinking about the liquid side of things. So I primarily work in the US, but I'm sure there's a number of options for collaborating with people in other countries as well, because most of the organizations out there that are doing this work in other countries besides the US.
Jillian, and I can also follow up. We have some colleagues in India at the Nature Conservancy that I'm sure would really love to connect. So I'll make sure to get, if you can drop your contact information, and I'm trying to look back. I think that was Saskana. With that question, I'll follow up and connect you to those colleagues. All right, our next question is for Katie. And they said, great. case study examples, are there ways to also monitor these ongoing behavior change actions in the community examples shared?
Yeah, that's a great case. I would say it probably, or a great question. I think it depends on the given case study. Unfortunately, a lot of behavior change interventions are kind of only monitored to the end of that solution or intervention. But I think our recommendation is to find ways of doing things like pulse monitoring, where you are checking in every few months or quarter or annually to see whether those results are changing. We just released a course on behavior change assessment on our website, which could be a great resource if you'd like to learn more about that. I'd say it probably varies in the various case studies, though, in terms of how they're monitoring and evaluating.
Thanks, Katie. And then Ali, we have a question for you. Are there any lessons learned that you could share from the United States that we could extract to an international audience?
Yeah, I mean, I think a lot of things that are done in policy, it feels like they're very US specific, but when you really break it down into figuring out how to make structure, like policy structures that allow you to make better decisions, a lot of these can be transferred internationally. The need for funding is going to be something that's pretty US specific as far as the function of how to do that. But the informed decision making and using best available data and science in order to create standard regulations that set a bar for everybody to meet as far as discharge permits and things like that. All of those things I think transfer really well internationally. And so lifting up ways that we've done it in a variety of different cities in the United States, I think lessons can be learned from the way that we do things, but I do acknowledge that like a lot of them also will be site specific. I mean, every coastal community is going to have their own needs. And so bringing the most valuable pieces from each example and then combining them into a unique solution for your community, I think is going to be the best way to do it.
Thanks, Ali. And we have one more question for you, Katie. And this is probably going to be the last question of the session. So it's 7% doesn't sound like a significant behavioral change. So what is the wastewater treatment plant operator's incentive to outperform their neighbor besides compliance? And I think this was regarding one of your case studies.
Yeah, it's also a great question. So I think what's interesting here is that we're finding just the power of that social comparison or influence. And so in this case, what we're finding, just because we as humans we're social beings, so we're really responsive to just what other people are doing around us. And so the willingness to comply may be connected really to just wanting to be within the social norms. We just have this innate interest and desire to be kind of matching what others are doing around us. And this can have interesting rebound effects, where if you're someone who's already discharging just a little bit and you find out the norm is discharging more, you may actually discharge more to reach more of that norm. So it can kind of go both ways. But in this case, I think what we're seeing is that if you're polluting more than others, then the incentive is to actually match that social norm. So it's really happening at that more psychological level. Hope that helps. Thanks.
Awesome. Well, thank you. I think we are just about out of time. And again, drop your emails if you'd like to hear any follow-up from us. And we really appreciate the questions and comments in the chat. And thank you so much. We hope you enjoy the rest of your World Water Week.